Okay, today we will discuss some basic discrete time signal. Okay, today we will discuss basic discrete signal. Clear? Now, what are the basic discrete signal? First is unit step signal. This unit step signal defined as u of n equals to 1 for n greater than equals 0 and 0 for n less than 0. Okay, means like this. If you want to represent graphically, it is easy to represent graphically. 0, 1, 2, 3 will go up to infinity. And what is this value? It is a 1. Clear? And next is unit impulse signal. It is very important. Impulse signal always important, plays a very important role for all calculation. Okay, in the signal system, both unit step signal and impulse signal plays very important role. Especially impulse signal plays a very important role. What is impulse signal? This impulse signal is represented by del of n equals to 1 for n equals to 0 and 0 otherwise. Okay, now how we can represent? We can represent like this. Okay, here 1 is a amplitude. This is your n and this is your del of n. Clear? Similar here, this is your n, this is a u of n. This is very important. This is your unit impulse signal. Del of n equals to 1 for n equals 0, 0 otherwise. Okay, here also we can say that it is a idealistic signal. Okay, it's not a practical signal because n equals 0 means 0 time means not exist. Okay, so this is an idealistic signal, but it is very useful for all mathematics point of view and for all mathematical simplification point of view in the signal system course. Clear? Now, next is your ramp signal. Ramp signal. These all are discrete domain. Clear? It is represented by or defined by r of n equals to n for n greater than equals 0 and 0 for n less than 0. Okay, how is the representation? It's very simple. Okay, you can represent when n equals 0, r of n equals to n equals 0 means it is 0, n equals to 1 means it is 1, n equals to 2, it is 2, n equals to 3, it is 3. Okay, similarly n equals to 4, it is a 4, like this. Okay, this is your REM signal. Next is your exponential signal. Next is your exponential signal. Here also I can represent like this, exp of n equals to r to power n. Now here different cases you will get depends upon the value of r. Okay, if r is greater than 1, if r is greater than 1, okay, then let r equals to 2. Then what is x of xp of n? It is 2 to power n. Now try to plot. If you plot, what will you get? It's very easy. N equals to 0. If you want to plot n equals to 0, it is 2 to power 0, 1. N equals to 1, 2 to power 1, it is 2. N equals to 2, 2 to power 2 means it is 2 to power 2 means it is 4. N equals to 3, 2 to power 3, it is 8. Okay, like this it will go. Similarly, n equals to minus 1, it is 2 to power minus 1, 1 by 2 means 0.5. Okay, n equals to minus 2 means 2 to power minus 2. 2 to power minus 2 means 1 by 4. 1 by 4 means 0.25. It is 0.25. Clear? Now if you see this plot, how it is looking, see, from small value to it is going up to high value. So we can say it's a exponential increasing signal. This is your exponential increasing signal. Okay, this is when r greater than 1. Clear? When r greater than 1, you are getting a exponential increasing signal. Now let I will take some other value. Let another case I am taking. If r lies between 0 to 1. First I have taken greater than 1. Now it is lies between 0 to 1. Then what will get? Let some value I am taking. Let r equals to 0.5. Okay. Now it lies between 0 to 1. Then again, what is exp of n? Exponential signal. It is r to power n, that is 0.5 to power n. Now try to plot this. What will get? Now if you plot, it's very easy. N equals to 0. What? N equals 0, it is 1, because 0.5 to power 0, it is 1. N equals to 1, 0.5 to power 1, it is 0.5. N equals to 2, 0.5 to power 2. Okay, it is means 1 by 2 to power 2 means 1 by 4. Yes or not? n equals to 2 means 0.5 means 1 by 2 to power 2, that is 1 by 4, it is 0.25. Similarly, n equals 3, 1 by 2 to power 3, yes or not? N equals 3, 1 by 2 to power 3, it is 1 by 8, 1 by 8 means 0.125. Okay, and when you take n equals to minus 1, how much will you get? If you take n equals to minus 1, then 0.5 to power minus 1, that is equals to 2. Similarly, n equals to minus 2, if you take, how much will you get? 0.5 to power minus 2, it is 4. It is 4, like this. So what are you getting? If you see this signal, now it is from higher value to you are getting lower value, yes or not? It is decreasing, higher to it's coming higher to lower. So what type of signal this is? This is exponential decreasing signal. Exponential decreasing signal. No, clear? Then come to next case. Are you clear? This is the exponential decreasing signal. Next case. Case 3. If R is less than minus 1, so what will you get? If R is less than minus 1 means let R equals to minus 2. Then exp of n is minus 2 to power n. Now do the plot. Again it is simple. Try to do the plot. Now when n equals 0, minus 2 to power 0, it is 1. When n equals to 1, it is minus 2. N equals to 1, it is minus 2. Sorry. N equals to 1, it is minus 2. Now when n equals to 2, n equals to 2 means minus 2 to power 2, it is 4. It is 4. Okay, similarly when n equals to minus 1, it is minus 2 to power minus 1, yes or not? N equals to minus 1, it is minus 2 to power minus 1. So how much it is? It is minus 1 by 2. So it is minus 0.25. So it is n equals to minus 1 minus 0.25. Similarly, n equals to minus 2. How much will you get? N equals to minus 2, it is minus 2 to power minus 2. Okay, that is your 1 by 4. Sorry, it is minus 1 by 2 means it's not 0.25, it is minus 0.5. Sorry, it is minus 0.5. Okay, now n equals to minus 2, minus 2 to power minus 2, it is 1 by 4. Simple 0.25. Okay. Now, what type of signal this is? If you see, what will comment? What type of signal this is? It's very simple. Now see, here sign is changing, plus minus is another. And also if you see from left to right, what are getting? Initially small value, say 0.25, then the value means magnitude of this value is increasing, yes or not? Magnitude of this value is 0.25, then magnitude of minus 0.5 is 0.5. Magnitude of this value is increasing. So it is no doubt it's an increasing signal, but not single sign, yes or not? Because it's plus minus coming. Na? So what type of signal this is? We can say alternative sign, exponential increasing signal. Okay, we can write like this. It is a alternative sign exponential its alternative sign exponential alternative exponential increasing signal. Okay, so what you got? If r less than -1, so you are getting alternative sign exponential increasing signal. Then what is the last case? We can say case 4. Case 4, if this r lies between -1 to 0, it's greater than -1, less than 0. Okay, let r equals to minus 0.5. Then what is the exponential signal? Minus 0.5 to power n. Now plot it. It's the same process. Now plot it. If you plot same, n equals 0, it is 1. N equals to 0, it is because minus 0.5 to power 0, it is 1. Okay, these are n values. Now when n equals to 1, it's minus 0.5 to 1, it is minus 0.5. When n equals to 1, when n equals to 2, minus 0.5 to power 2. Minus 0.5 to power 2 means how much? Minus n equals to 2, it's minus 0.5 to power 2. How much this is? That is 1 by 4, yes or not? It is equals to 0.25. So n equals to 2, it is 0.25. Okay. Similarly, when n equals to 3, it is minus 1 by 8, means how much? It's a minus 0.125. Similarly, left hand side, when n equals to minus 1, how much will you get? N equals to minus 1 means it is minus 0.5 to power minus 1. That is how much? Anyone? It is minus 2. Correct? Okay. So it is minus 2 when it is minus 1. Okay. Now see, if you see this signal, what you are getting? Again see, it is not single sign. Plus minus is coming. And if you see from left to right, what you are observing, initially high value, then slowly this amplitude is decreasing. Yes or not? So what type of signal this is? Obviously it is exponential decreasing signal. Yes or not? If you see these amplitudes are decreasing. Okay. Here also if you see, these amplitudes are decreasing. Yes or not? So what type of signal this is? We can say alternative sign exponential decreasing signal. We can write alternative sign exponential decreasing signal. Clear? Because no doubt the value is decreasing. Say 1, if it's the 0.25, in positive side it is decreasing, in the negative side also it is decreasing. So it is a alternative sign exponential decreasing signal. Like previous, if you see in this previous case, okay, in this case means when r is less than minus 1, if you see in the positive side the amplitude is increasing. Okay, similarly in the negative side also it is increasing. Okay, minus 0.5 is minus 2 means little more. Okay, that's why in positive side it is increasing, negative side also it is increasing. Okay, means magnitude of the amplitude I am saying increasing. That's why alternative sign exponential increasing signal, and in this case it's alternate sign exponential decreasing signal. Okay, so based on the value of this r, we are getting 4 cases. Already we discussed. Yes or not? We are getting 4 cases. What? First case is if r is greater than 1, if r is greater than 1, then say it is increasing, it is increasing, that's why exponential increasing signal. Now when r lies between 0 to 1, if you see this plot, it is decreasing, the plot is decreasing, that's why exponential decreasing signal. When r less than -1, already said, it is a alternative sign, exponential increasing signal. And finally, when r lies between -1 to 0, its alternative sign, exponential decreasing signal. Okay, these are the 4 cases of exponential signal in discrete time domain. Clear? Now similarly, sinusoidal signal, you all people know, we can write sinusoidal signal. It is yes or not? How you can represent a sine of omega 0 n plus phi. Okay, or you can write a cos of omega 0 n plus phi. Okay, plot also already you know, you people, it's not difficult. Let I am taking phi equals to 0. If you take phi equals to 0, then this is the plot will get for sine. Why given dot? Because it is not continuous, it is discrete, yes or not? That's why I given dots. In case of continuous, you will get a continuous plot, but here I am giving dots because it is a discrete domain. Okay, this n, and this is your this is a, this is a minus a, and this is your a sine of omega 0 n. Similarly, you can do for cos. Okay, similarly you can do for cos. Okay, like this, n, and this is also a, this is your minus a, this is your a cos of omega 0 n. Okay, clear? Now if you here phi is 0, in both cases I taken phi equals to 0. If you take some phi value, then what will happen? It will shift to left hand side. Okay, if you take some phi value, instead of starting from here, it will shift to left hand side. Okay, similarly, if you take some phi value, instead of starting from here, it will shift a little left hand side. Okay, clear? It's easy, not difficult to plot. Simple, if you take some phi value means what will happen? It will shift like this, it will shift some value and will get the plot like this. Okay, so this is your a sine of omega 0 n plus phi. It will shift left hand side. Okay, and what is this value exactly? This is your a sine phi, yes or not? This is your a sine phi. Same case will get in case of cos. It depends upon the value of phi. It depends upon the value of phi. Okay, it will shift left hand side. Similarly, in case of cos also, if you want, you can do. It's not difficult. Same thing, we will shift. See, I am not giving exact because we don't know the value of this phi. That's why I am giving this just approximate plot. Same thing, it will shift. Again, I want to say it's not exact plot. Just some plot I am giving. Okay, this is your A cos of omega 0 n plus phi. Okay, clear? Here is shifting left hand side this phi value. Here also this point, if you take this point, it's some phi value. Okay, this is your sinusoidal signal. These are the basic discrete time signal. I hope you people understand. Today we discuss all the basic sign means discrete time signal starting from unit step signal. Okay, quick revision. Okay, first unit step signal, it is 1 for n greater than 0 and 0 for n less than 0. Then important one, impulse signal, 1 for n equals 0 and 0 for n not equals 0, or otherwise, or you can say n not equals to 0. After that, we discuss ramp signal, r of n equals to n for n greater than equals 0 and 0 for n less than 0. Then exponential signal, 4 cases. Okay, exponential signal, it is r to power n. This is the main for all n. Then 4 cases, r greater than 1 means it's exponential increasing exponential. It is exponential increasing signal. Then r lies between 0 to 1. It is exponential decreasing signal. Then r is less than minus 1. R is less than minus 1. What we got? Alternate sign exponential increasing signal. And finally, when r is lies between minus 1 to 0, it is a alternate sign exponential decreasing signal. So 4 cases we are getting with respect to the value of r. Then this is simple sinusoidal signal. Sinusoidal means cosine or sine. A sin omega 0 n plus phi, it's a sine signal, and a cos omega 0 n plus pi, it is a cosine signal. Both sine and cosine signal known as a sinusoidal signal. And this is the plot I given in dot because it is a discrete time signal, not a continuous time signal. Okay, thank you.